All right, it's a couple minutes after, so I think we're safe to get started. Thank you everybody for joining us. My name is Angela Rodenberg. I am the VP of Marketing for Redwood Plastics and Rubber. And today presenting is going to be Kevin Smith. Kevin, if you want to put the slide one above, I'll give Kevin a little bit of an intro. Technical difficulties. Yeah. So obviously today's presentation is about smarter food safety. So we'll be going through a lot of applications and information in regards to plastics and rubber and how they can prevent recalls, how they can prevent contamination, how they can increase the speed of processing in food and beverage facilities. Kevin is very well versed in the food and beverage and packaging and industries. He's also heavily involved in other industries as well, as you can see, in agriculture, heavy equipment, military, marine. He's been in the plastics industry for over 15 years. He definitely has a passion for bearing and bushing applications, which you'll see later on in the presentation, but his experience is quite vast. So if anybody has any questions during or after this presentation, they can certainly reach out to Kevin or myself or any one of our plastic and rubber experts within our team. So with that, I will hand it over to Kevin, and if anybody has any questions during, you can put it in the question box that's up on the right-hand corner of the screen, and at the end of the presentation, we'll answer as many questions as we can, and like I said, we can always fill some questions afterwards as well. So take it away, Kevin.
Hi, good morning, everybody. Thanks, Angela. I know that folks that are listening are kind of scattered all over the place. I'm located in Woodlands, in Redwood's Woodland facility down here outside of Portland, Oregon. So I have done a lot of work up in Canada and other parts of the world, but most of my experience has been here in the United States. So I can talk about the regulations as they apply here in the US. So about 10 years ago, in 2011, the Obama administration signed the Food Safety Modernization Act to give the FDA, the regulating body here in the US, new authorities to regulate the way that foods are grown, harvested, and processed. And that law granted the FDA a number of new powers, including mandatory recall authority, which they didn't have in the past. During facility inspections, agents can look for any areas and niches that they feel might be a harboring point for bacteria, and these agents can take anywhere from up to 200 swabs on different parts of the equipment, depending on how big the facility is, what the product is, who the customer is, things of that nature. And at that time, the raw agent can also take raw samples as well as finished product. Here on the screen, the remaining bullet points are some of the topics I'll be discussing in this webinar. And as Angela said, if you have any questions, you can just write them there or hold them to the end. So this slide contains some of the scary verbiage detailing the consequences of willful non-compliance. I've heard of a lot of non-compliance issues, but I haven't actually seen too many of them here in the United States. Generally, because most folks understand the cost of recalls and image damage related to sloppy procedures and unmaintained equipment. With regard to the preventive controls, it says there more and more producers and packagers of food items do seem to be incorporating inspection equipment that have X-ray or metal detection capabilities. And this is one of the ways that we can be of help. Some of the benefits of utilizing more plastic in your facility, mostly taking the place of metal components and bearings, is that many plastics have self-lubricating properties, even at high temperatures. Plastics are more resistant to corrosion and chemical attack. This is particularly beneficial in facilities that use parasitic acids, the PAAs, as antimicrobial agents on the processing equipment. I know that PAA is sometimes used in the field also. I've experienced that with apple producers. So that it does get used in crops. It gets used in dairy and cheese plants. Parasitic acids and some of the other cleaning and decontaminating agents can be quite corrosive. I experienced this a lot in bearings, where the PAAs really are corrosive to bearings. Plastic, depending on the type, is very good at resisting impact and noise damping. Some of the factories I visit are quite noisy, especially in drag chain, sprocket, gear applications, and of course anywhere where there's impact. The self-lubricating properties are particularly good at friction reduction, and any reduction of friction helps to keep energy costs down because drive motors require less amp draw. This also helps to protect the life of the motor, the gearboxes, conveyor belts, and so forth. Okay, so this slide simply details where Redwood engineers have worked and continue to work pretty much on a daily basis. Most of you folks listening either work in one of these industries or at least conduct work for your clients in these industries, or you will be working in these industries. Although there are a lot of common traits among these industries, companies serving these markets do have specific requirements and applications that make them unique. I personally spend a lot of time in fish processing plants and commercial bakeries here in the area where I live and work. There's not a great deal of commonality between fish processing plants and commercial bakeries, except that you're dealing with a highly perishable product when you compare it to wine or beer, or potatoes or onions. Those things tend to have a little bit longer shelf life. The first bullet point, meat and chicken, etc. These are places where the equipment is constantly being washed down and decontaminated. It's generally a very bad environment for grease lubricated bearings. Commercial bakeries don't get washed down in the same way, but I know that there are some bakery folks out there listening, and you know that the abrasive nature of flour and the temperatures at or near some of the equipment, like the ovens or the proofers, can dramatically shorten the life of a plastic part if the type of material chosen for that part is not compatible for the application. Fruit and vegetable farming, processing, packing. This is generally a fairly dirty job. Equipment components tend to wear out pretty quick. Some parts have to be replaced every season. I see that a lot. Sometimes a material change can make the part last multiple seasons before needing to be replaced. In some of the really dirty places, like the blueberry field on the harvesting equipment, I know that some of that equipment the components have to be changed out every season. And by working with Redwood, we've increased the part life on some of the components in the harvesting equipment to over 5 seasons. I know that it's possible to even go as high as maybe 8 seasons on some of these components, which is a big deal, actually. In beverage and canning facilities, custom components made from high wear plastics often replace metal parts in components like filler heads, indexing cams, metering pistons, manifolds. I think I've got some pictures of the pistons and manifolds. Star wheels, conveying screws, things like that. I think that there are some grain or some seed guys out there listening today. We've done quite a lot of work in that industry. Plastics replace metal components in hoppers and chute liners. Because these products are generally dry and quite abrasive, we're generally speccing in our Redwood rubbers and polyurethane materials for things like chute and hopper liners. It not only increases the life of the equipment, but it does have a tendency to reduce impact damage on the product as well, which is always a good thing. This slide gives you a quick glimpse of components that are commonly used in the food industry, familiar to pretty much all of you, I reckon. Looking over this list, there are some components that should be here. Some are obvious, like chain channel, wear strips, seals, cutting boards, of course. But there's also components like flight boards, high temperature tapes for heat sealers, polycarbonate machine guards that should be included on this list because we make so many of them and they're in just about every facility. Okay, here's a list of some of the usual suspects. I expect that a lot of you guys will recognize pretty much all of these. You find most of them of these materials in just about every industry. Right there at the top, UHMW, that's everybody's go-to plastic because it's cheap, it's compliant, it's usually available. A little bit of a problem with that these days due to the storms and the fires down in Texas, making resin availability a little short. Hopefully that will clear up by the end of summer. It has a fantastic impact, chemical resistance. It's got relatively good property for wear, but because of its terrible thermal properties, it grows and shrinks in temperature changes worse than just about any plastic. It really should be avoided in most bearing applications. Hdpe, a lot less expensive. This is the preferred material for cutting boards, more than UHMW. It doesn't dull the knives quite so much. And it's a good structural material. Acetal, a bit more expensive than UHMW, but has better thermal properties. Can be used in bearing applications, providing the loads and speeds are not too severe. We can talk about that a little bit later. Nylon's a good material for machine components like gears and sprockets, conveying screws. PEEK. This material is the go-to when all other plastics fall short, if you can afford it, because it's really expensive. PEEK, PE, polyether ketone. It's a fantastic material in high wear applications. As a side note, and didn't put it on the slide, probably should have, the PPS is often a good alternative for PEEK. It has similar properties, and mostly all that you're going to sacrifice by going to PPS is a lower maximum temperature potential. I think I put that somewhere else in the presentation. The rubbers listed here are generally employed as seals or as vibration or impact damping. The same is true for the urethane materials, although typically these are either as a formed finished component or as to recoat rollers, which we do quite a lot of actually. PVC, it's not one of the more common materials in the food industry, but it does get used in components like belting, clear strips, PVC hanging curtains, diverter arms. Just made a bunch of PVC diverter arms for a company that makes wine bottles. Polycarbonate, preferred material for machine guards. Some folks use acrylic, but polycarbonate has a higher strength. It's not flammable. It's more resistant to chemicals. It's lighter weight. Acrylic, of course, can be polished, and it's easier to buff out scratches. And it's a lot more visually clear. It's kind of a prettier plastic, and it's usually less expensive than polycarbonate if cost is a concern. But typically, for machine guards or anywhere where it's in a high use area, I tend to try to sway people into the polycarbonates. FRP, fiber reinforced plastic. Not a picture of it here, but there's a picture later. We use that as grading, or we supply that material as a grading that's used in areas where there's a lot of water or slipping hazards. It's commonly used in places like mezzanines and stairs. Okay, here's some typical components that are made from metal detectable materials. These are generally components that are in high wear applications and in direct food contact. Okay, on this list, probably not sprockets, gears, or pillow blocks. You can make those out of metal detectable materials, but they're not generally direct food contact, but certainly scraper blades and rollers are. Just because something isn't in food contact, and I'll talk about this a little bit later with the greases and the bearings, it doesn't mean that there isn't a potential for it to end up in the food stream. There really is. So you have to take it on a part-by-part basis, really. This slide shows that even a tiny piece of metal detectable plastic set off an alarm. I was in a commercial bakery recently to test this. The customer was trying to determine how small of a piece of plastic their detectors could detect. So we kind of played around with it. I had some metal detectable plastic in my truck, so I went out and got it, and I got my pocket knife and I shaved off some pieces. And we just took some regular Scotch tape and we taped little pieces of plastic to the bottom of muffins, and we stuck the muffins in bags with other muffins, sealed up the bags and threw them down the conveyor through the detector, and the detector caught it every single time. And we'd take the bag and we'd pull it out and put it in a different orientation, or we'd pile other bags on top of it. And this piece of metal detectable plastic that I taped to the bottom of a muffin was no bigger than just a little fleck of pepper, even smaller than the picture that's the piece that's in the picture there. Now, they may have just had a very, very good metal detector, but I understand you can kind of tune it to different sizes. All right, so sometimes metal or X-ray detection is overkill, and simple visual detection is good enough. You know, there's really three common detection methods. There's visual. You know, it's a different color than the product you're making, like blue in a commercial bakery where everything is white, the flour, the dough, all that stuff. So you got visual detection just by simply making it a different color. Or you've got X-ray detection, or you've got metal detection. You can get materials that have all of these things. Off the top of my head, I know of one that is metal, X-ray, and blue. Usually, you know, 1 out of 3 is good enough. So in cases like this, where almost no food is blue, using a blue plastic is good enough. A lot of the commercial bakeries that I visit, they like the blue because if a piece breaks off, you know, even on a table or under trays or under a conveyor, they can see it on the floor. If it were just a piece of white UHMW or Hdpe, you'd miss it when the cleaning crews came by with their brooms to sweep it up. So they actually like to see if pieces are breaking off so that they can redesign the equipment, change the materials, something like that, eliminate the potential or the future potential of plastic actually getting into the food and forcing a recall. So sometimes just going blue is good. A lot of materials have been compounded with additional internal lubricants to further decrease friction. You can see the benefits there bulleted. The benefits offered by these specially compounded materials. The overriding benefit here is lowering operating costs. It also improves and increases part life, but you really feel it in the lower operating costs by improving the performance of the components in the equipment. Here's some examples of products that Redwood offers in the area of employee safety. There's the FRP grading we talked about earlier for minimizing the potential for slipping and falling. You see this everywhere, on rooftops, inside factories, mostly on stairs and mezzanines. On the right, you can see the protective barriers there. This is especially relevant these days with the COVID. We make these barriers for lunchrooms, office spaces, work areas like control rooms and inspection stations. Okay, so say goodbye to grease. This is my favorite. Being a bearing guy, I've got a passion, as Angela said, for bearing applications, especially when the objective is eliminating lubrication grease, because pictures of dirty or over-greased bearings like you see there, they drive me crazy. In almost every application where a bearing is needed, except where high speed is concerned, a plastic bearing of the appropriate material will generally suffice. Sometimes you have to incorporate a seal. It doesn't have to be an expensive seal, to keep some of the big schmoo, some of the big particulates of contamination out of the bearing journal. But there's almost always a way that you can to get around. You really only need a rolling element bearing if there's a high speed potential. And even then, some of these we'll talk about that in a minute. What folks don't often realize is even if the grease being used is food safe approved, FDA approved, it's still a component where contamination can be trapped. It can be held there. It can be transferred to food products. Besides, even if the grease is food grade, and it always is, who wants to open up their bag of frozen carrots or peas and have a big glob of dirty grease, bearing grease, fall into their skillet? Typically, bearings are not components that are in direct contact with food, so you might think that the risk is minimal, and that's usually true, but bearing grease doesn't always stay in the bearing from which it oozed. You can tell there. Sometimes during machine washdown, the grease gets carried to areas where food contact is likely, and I can tell you, partner, I see this all the time. Sometimes it ends up on the floor and becomes a tripping hazard or a slip hazard. I've seen that a lot. It just gets everywhere. I could talk all day about this subject, but we need to move on. So if you have any specific questions about bearing applications related to eliminating grease, it's probably best that you talk to a Redwood engineer or call me or save your question at the end of the webinar and we can talk about that. But before moving on, This slide shows that the different maximum operating temperatures, loads, and speeds of plastic materials being used as bearings, mostly as replacements for grease rolling element bearings. When I say rolling element bearing, I think you know what I mean. Any bearing that has a ball bearing or rollers, you know, there's rolling parts in there that require additional lubrication, but can also seize and cause the equipment to stop working. In a plastic bearing or a non-rolling element bearing like we would make, there's no moving parts, so really there's nothing to seize. Your equipment won't stop working. Now you can't wear through a bearing. I see that a lot where the surface finish is too rough and you machine the bearing away, but that's pretty rare. If the guy speccing in the bearing knows the surface finish on the shaft, knows the speeds, the loads, and can match the material to the application. I've replaced a lot of rolling element bearings with plain bearings that have been running for, oh God, more than a decade, and they're still working. Some of them in fish places. And they've never been changed out, and they get washed down every 8 hours. Anyway, I just want to point out one thing though. Remember when I said that UHMW should be mostly avoided as a bearing? If you look at the maximum load and speed of a UHMW bearing down there on the bottom, and compare that to a more expensive bearing like a filled Teflon bearing, a filled Ptfe bearing, the UHMW has a maximum no load speed of 50 feet per minute versus 400 feet per minute to no load speed of a filled Ptfe bearing, and that's quite a difference. And what we're trying to do here is we're trying to eliminate heat, frictional heat from rotation, because to folks like us, heat and speed are the same thing. The more speed you apply to something in a friction application, the more heat you're going to get. And heat is the #1 killer of any type of polymer material. I'm talking plastics, rubbers, urethanes. Heat is a cancer to those materials. So heat needs to be, attention to how much heat is going into that material always plays a factor, especially in bearing applications where by nature everything is dynamic and moving. Anyway, talk too much about that. Not too sure how interested you folks are in discussing the pros and cons of every single food grade plastic there is, so we'll kind of go through these slides a little quick. PEEK, polyether ether ketone, as I mentioned, in the world of plastics, when all else fails, use PEEK. It is expensive, but it does have superior wear properties and handles quite high continuous service temperatures nicely. We're talking about 480 degrees F, 249 C. PPS, which I also mentioned earlier, has similar properties structurally and wear-wise to PEEK. It has a maximum operating temperature of about 425 F or 218 C. So you're only giving up about 60 degrees Fahrenheit of upper range performance, but you're saving a lot of money. So there are options. PETs, I really like this material. It's not very expensive. It's easy to machine, has excellent wear properties, good chemical resistance. It has an upper operating temperature. That's a continuous operating temperature of about 210 degrees Fahrenheit. So it's still better than UHMW, which maxes out around 180 in a lot of applications, especially as a bearing or as a close tolerance machine part. There's a bearing there on the right hand side. That's replacing a rolling element bearing or the insert for a rolling element bearing. It's a very good material. I also like that the TX version of the PET is kind of that gray material. There aren't a lot of gray plastics out there, so I really appreciate it when the manufacturers of these plastics give these plastics a unique color that you can kind of spot from 10 feet away and say, oh, I know what that is, without even going over there and feeling it. So I do appreciate that. It's a good material. I really like it. The acetyls, there's two common versions. There's just regular acetyl, which is a copolymer, and Delrin, which a lot of folks know. It's still acetyl, but it is a homopolymer, so there's a little bit of different performance characteristics, mostly having to do with water absorption and things like that. And Delrin is a trademark name by DuPont. So all Delrins are acetyls, but not all acetyls are Delrin. ask your Redwood guy which one you should be using. The primary benefits are listed there. It's got good dimensional stability, a continuous maximum operating temperature of about 180 degrees Fahrenheit, which is the same as UHMW, but it has a lower coefficient of thermal expansion than UHMW, so you can make tighter tolerance parts. Probably not bearings though, but because of the speed and the temperature. Remember, we said temperature and speed are the same thing in bearing applications, so you got to be careful with acetylene bearing applications, especially if there's a real load there. Okay, so like UHMWs and nylons and things like that, Ptfe or Teflons, they can be either filled or unfilled. Filled Ptfes, filled Teflon materials, they're wonderful. They've got high operating temperatures. They're largely chemically inert to most things. They make very good bearings, very good slide pads, very good finished components to tolerance. You may recognize names like Rulon or Fluorescent. Redwood Plastics has its own FP series, filled Teflon or filled Ptfe series. That's quite good. But a lot of folks shun these brand name filled Ptfe materials like Rulons and Fluorescent because of the high cost. However, there are generic alternatives. Redwood itself makes an alternative that's across the board the same as the name brand stuff. So please make sure that you speak with a Redwood guy before dismissing these filled Ptfes out of hand simply due to price. The bottom line, and this is kind of important, is that these types of materials can outperform other types of plastics in a lot of different ways, especially in the food industry, where you've got temperatures, you've got speeds, you've got high washdown potentials. Ptfe, basically we're just talking about Teflon here. It's a good material in applications where high temperature or chemical resistance is required. So you see it a lot in seals, gasketing, things like that. But being a soft material, it has limited applications structurally. But there is a large variety of dynamic and static applications where the material does fit nicely. Okay, UHMW. Like everything else, the nylons, the Ptfes, there's filled and unfilled versions. Okay, UHMW, when compounded with different types of fillers like oils or solid lubricants, it's a great material. So, and even when it's filled, it's generally pretty low price workhorse when you compare it to other engineered or performance plastics. In certain applications, it can outperform unfilled UHMW by 10 times more or less. And there's abrasive resistant versions. There's all kinds of different, but for the food industry, we're looking primarily for lubrication. Regular unfilled UHMW, always the go-to in the plastics world for so many applications. It has some of the highest direct impact resistance parameters when you compare it to other plastics. It's not too expensive, relatively wise. Everybody's used to it. It's cheaper than beer. You can get it everywhere. Well, not anymore, but you can get it in a lot of different colors. It's got a lot of wonderful properties, but you still have to be wary of UHMWs because it's not a great material choice for bearings or high tolerance parts, high tolerance components, due to its poor thermal properties. Okay, just kind of been boring you with a lot of verbiage and words, so we're just going to look at some pictures here. I just want to sum some things up. We can flick through these remaining slides to show you what kind of parts can be easily fabricated from food grade plastics, many of which are currently offered by OEMs and materials that are less than ideal from a corrosion or high wear perspective. And most of the pictures you're going to see here, a lot of them are just from my iPhone. You can see on the right hand side, pardon me, all the broken pieces. That's direct food contact. If you look on the left, you can see that this is a fruit and vegetable packing place. Broken parts pretty much everywhere. These facilities never shut down. These materials always end up in the food. So they call me out. I'm into this particular plant just about every week, trying to repair broken places and work with their engineers on equipment improvements to keep so much broken stuff parts from getting broken or potentially ending up in the food. It's a never-ending battle because it just doesn't stop. It's 24/7 operation. These are pictures from a potato chip plant down in Oregon. These are all parts that we manufacture, from chain guides to bearings. Those are flange bearings because they do have some axial and radial loads. We even do some of the tooling on the fryers and the roll recoating. Hopefully these images are you recognize some of these parts. In this case, this is a commercial bakery. This is for the proofer rollers. You can see on the lower left, they were using a sintered bronze lubricated bearing, thousands of them in these rollers. You can see an assembled roller on the top left. They just were not lasting. It's a very high heat environment, not too fast moving, not significant loads, but we did replace it with a composite plastic bearing there on the right hand side. What you see there in the green inside that roller, the bearing is pressed into the roller there to replace that sintered bronze bearing. That's a filled Ptfe that I talked about earlier. So it is filled with a food grade or food safe material. It really makes that Ptfe much stronger, much better wear resistance. The sintered bronze bearings, they were changing out at least once every 2 years. The plastic ones we put in, they've been running now non-stop for, trying to think, maybe close to 7-8 years now without any maintenance. So they've already improved the lifetime by 4, and they're still running. So I expect they're going to get at least 10 years out of these bearings, where they were changing them out every, I think 18 months was the number they were giving me. And they weren't that expensive either. They're pretty cheap. Another bread factory. You can see the upper and lower plates there are all UHMW. So we replaced all those. They had originally started out as stainless steel. We made more out of UHMW, adding the grooving, changing the hole pattern so that the dough or the flour would not accumulate. These are the balls that are going straight into the proofer, the dough balls. More commercial bakery, blue slides. They did not want white. They wanted to convert all the plastics over to blue, and they had 5 years to do it. So we're still chugging through. So everywhere you see white plastic will eventually be blue plastic. This is a large-scale commercial bakery. A lot of the machines, we did all of the plastic guards, all on polycarbonate. So pretty much everything you see there has been replaced with new polycarbonate. And that was because the inspectors came through, or the customer came through rather, and they wanted all the guards replaced in the entire factory for all the processing equipment. They didn't want to see a single chip, a single nick, anything before they awarded the contract to the commercial bakery to start making their product. So we had to go through, measure the Redwood. We went through, measured every machine guard in the place, and converted it over to newer, better plastics. Gears, the one on the right is the one that we made, based on the one that the customer handed me on the left. Rollers, we do a lot of rollers at Redwood. Mostly polyurethane and rubber, but we can also do rigid polymer. These are out of a different commercial bakery. You can see that they are actually Ptfe. They've got a sleeve, a plastic sleeve over a metal core roller, and they wear down. So we cut those off and we fabricate new rollers. Sorry, Angela, I should have taken pictures of the rollers after we were finished because they looked really pretty. So just imagine these looking really nice and not all worn down or dirty at all. And that's what they look like. We do a lot of those. Okay, and just more custom parts. There you can see on the left-hand side another roller for a chocolatier for making candies. And the one next to it is a mold plate for salmon and halibut patties. That looks like a V-wheel roller and a urethane sprocket. FDA rubber. food grade rubber seals and edge guard protectors. On the left hand side there, you can see that we had made some virgin nylon side plates for appears to be a commercial proofer. I didn't actually see this equipment. I didn't take these pictures, but I know that that's a proof box or proof box configuration for dough. On the right hand side, those just look like Delrin or UHMW level feet things for the tables. Conveyor components slide. The one on the left I really like. That's a low slide, high wear plastic. Diverter arms, generally these are stainless steel, but if you make them out of, in this case, these were acetyl, you get a lot longer life out of them. They're lower weight, less wear and tear on the drive mechanisms. Originally, I thought these were worm gears, but they actually turned out to be some products we made up in Canada. These are auger screws for peanut butter and cookie dough, I think. Yeah, cookie dough. Those would normally be stainless steel. More nylon and acetyl parts, diverter arms. Oh, I like this picture. So all of these little packing meter boxes, you can see that we've replaced all of the bearings, which are normally a sintered or oil impregnated bronze bearing, with a metal detectable UHMW. You can see that this is not only a spacer, but it's also due to the, you can see the flange there. You can see how it's configured, that it's also the bearing to replace the sintered bronze. So it is acting both as a radial bearing and as a axial load bearing there on the thrust side where the flange is. Now, this is something that you can see it's directly over food as the food drops into, I don't know what this is. This could be nuts or candy or frozen corn. I see these things everywhere. Although they're not in direct food contact, you could see that as they wear, pieces break off or fluff off. They could obviously drop down into the bins below it and get mixed in with the food. So this is a great application for a metal detectable polymer. Modified star wheel for product spacing. That looks like a jar sorter, probably going through a labeler. The weight savings of making this thing out of a polymer versus a metal, just fantastic. You're really going to save a lot of money energy-wise driving a wheel, a lighter weight plastic wheel than a fabricated metal wheel. Rollers, looks like we're pressing out some granola bars or protein bars there on the right. So we do complete stripping and recoating of rollers in-house. Still have a metal scraper on that one's on the right. I guess that's okay. Typically, you would make a scraper like that out of a PEEK, and it would probably last a lot longer than the metal. PVC curtains. I was going to make a joke that that's me on the right, but I don't think I can pass that joke off. And that's it. Happy to entertain any questions you have.
Thanks, Kevin.
Oh, you scared me. I thought I did the whole presentation with my mic muted.
No. I would have given you a bit of heads up with that. I am going to give you trouble for not taking pictures of those completed rollers, though.
You know what? I've got them. I actually, because I'm into that particular commercial bakery every week, I tend to just pick up the stuff and take them because it's so close. So I do all the pickup and delivery myself, just because I'm always in there. But and they turned out really, really well this last batch. And I've got 4 more rollers in there right now, and then there's a whole boatload more coming because they really like the job that our Canadian branch did on those rollers. So I'm very, very grateful that the work done there was really good quality. And I've got pictures, I just don't know where they are. They're somewhere on my phone, but.
So we're going to open up to questions. Like I said, if anybody has a question, you can write it in the Q&A little box that's on the right-hand side of your screen. So we have one question so far. can I still grease my plastic bearings?
Yeah, that's a great question. That one comes up a lot. So typically, and I don't know what the experience of the other Redwood guys when they're going into food processing or packing places, or any company that deals with even harvesting or farms or seed producers or packagers. You know, the thing I get all the time is I've tried plastic in the past, and it, you know, for this part or this component, and it just didn't work. And that's always surprising to me, because generally the go-to is UHMW. So they try to put a UHMW part in there, and then they're really shocked that it didn't work. And it's like, well, then you start to do the math with them to show them exactly why it didn't work and why it was the wrong material. And they, you know, or I'll go into a place and I'll see plastic bearings. I was in a frozen food packer last year. They pack carrots and corn and such, and they had plastic bearings in there, but there was still grease just blowing out of everywhere. And you can't grease a plastic bearing the same way that you do a rolling element bearing, because there's nowhere for the grease to go. As I said, there's no moving parts in a plastic bearing. The shaft just rotates within the bearing itself. So there's no really good grease path to lubricate that. So they were just pumping grease and grease in there to get more speed out of it to keep from melting the UHMW. Although UHMW doesn't really melt, it's not thermoplastic, but it does burn up, which is what they were doing. And so to answer your question, yes, you can't, not really. Typically, you're not going to want to add grease to a plastic bearing. Now, you can get plastic bearings, and we do make them, and I'm including composites in here, where you do machine a grease groove into it, and then you put a seal. So if you absolutely need to grease a non-grease bearing or a plastic bearing, you can do it, but there's caveats to it. And the only reason I would ever suggest in greasing a plastic bearing or designing or building a plastic bearing with grease grooves into it is to get more speed out of the bearing. So if you've got a UHMW, I don't know, can I go back in the thing here? Yeah, I can. Let's go back to that. This is really kind of important, so I want to make sure that this is well understood. Only time I would ever recommend greasing a bearing is, I thought I had a picture of a grease bearing in here. Okay, whoop, there we go. There we go. So you can see the max loads, top bar, you got the max temperature, the coefficient of friction, the max load in pounds, and the static PSI, the P value, the V value there. So if you look at the bottom, you can get about 50 feet per minute out of a UHMW bearing. Now that's not under load, but let's pretend it is. If I needed to get more speed out of that, let's say this was on a conveyor line and that conveyor line was traveling 60 feet per minute and the bearing I know is only rated for 50 feet per minute, could you machine that same bearing with some grease grooves in there, put a squirt of grease in there, not a lot, just a little, put in there, and then get that extra 10 to 15 feet per minute out of that bearing? Yes, you could, because the grease will kind of eliminate that published V value or the velocity value for that plastic. I don't encourage that. I generally discourage greasing non-greased bearings, because grease, as I said before, it's not going to get changed out. Everybody says that they've got a good lubrication procedure, but really most people don't. So they'll either under-grease bearings or they'll over-grease bearings, and what they'll do here is they'll squirt grease in and they'll keep pumping grease in until they see it squirting out, and then they'll walk away. All that grease is going to get contaminated and foul over time. Stuff is going to get attracted to it, like dirt or food products and stuff like that, and it's just going to get worse, and it's going to get worse, and eventually that grease has got to go somewhere. And I see this everywhere. So for that reason, I generally discourage greasing. So the only time I ever encourage greasing or we'll talk about that it's okay to grease a plastic bearing or a composite bearing if you need to get more speed out of it, if you just need that extra little oomph, then you can do it. If you need to purge contaminants, because it's a very dirty environment, we talk about putting plastic in harvesting equipment. Look, you got to keep the bearing journals or that running clearance between the shaft or the pin and the bearing free of abrasive contaminants like dirt. If you're not going to put a seal in there, then at least purge it with grease every night just to get it out, and then wipe up the excess. Or sometimes you need to, and this isn't often the case in food processing plants, but it is in farming and seeds and things like that. There are people that are running plastic bearings on metal, mild steel shafts. Those shafts will rust over time, and then that rusty surface will act as an abrasive and machine the plastic away. So I do encourage you putting just one squirt of grease, or just put a little bit of grease on the end of your finger and then greasing that metal to keep it from rusting. So it has nothing to do with speed or lubricating properties from a bearing standpoint. You're only trying to put a coating of grease on that metal pin to keep it from rusting and forming an oxide. Generally, you don't see that inside food processing or packaging plants because everything is stainless, so you don't tend to get a lot of corrosive buildup on the stainless parts. But out in the field, or if your dock equipment or your loading equipment or your packaging equipment or your palletizers equipment, things like that, if you got to keep those things. I thought I had some other pictures though. Somehow they didn't get onto the presentation. Doesn't matter. So generally, when it comes to lubricating plastic bearings, you really want to talk to somebody that understands plastic bearings to find out if it's a good idea or not. Not everybody out there understands all the dynamics surrounding bearing applications. They just try UHMW and they get mad that it doesn't work, or they get rather discouraged that it didn't work, without understanding that UHMW is about the worst plastic you can put into a bearing application, simply because it gets hot as it rotates, right? Friction equals heat, and UHMW expands with heat. So they'll put it on a pin, they'll rotate it. Plastics are terrible thermal conductivity issues. So the plastic doesn't get hot, the shaft just gets hot. So now you've got a piece of plastic like UHMW that's riding on a hot shaft, and it's getting hotter and hotter and expanding, and then it seizes onto the shaft. Or it puts so much drag on the shaft that the motor has to draw higher amps to work through that resistance of that bearing choking that shaft, and then the thermal overload protector on the motor switches off to save the motor. In the meantime, you're just eating up electricity, trying to pump more amps in that motor to churn through the resistance of the bearing. So they get discouraged and they go back to a rolling element bearing and just deal with the high cost of replacement. When in fact, if you just put in like a filled Teflon bearing in there to begin with, or maybe even a filled nylon or polyurethane bearing, they wouldn't have those issues anymore. I feel like I kind of went all over the place on that answer.
Okay, it's always one of those it depends answers.
Yeah, it really does. There's just no easy way to answer that kind of question as for adding additional lubricants to plastics, because then there's the different types of lubricants that you would use. Some of your composite materials do not like the EPs, the extreme pressure lubricants, because there's stuff compounded in lubricants that's bad for the plastic. It's whenever you're dealing with a bearing application, particularly, you really need to talk to somebody that understands plastic and the application. You need to know what the loads are, the speeds are, and how the bearing is going to perform. If you do that, if you just take the time to do that, it's very easy to get into a bearing that's going to last a long time and be very efficient. It's not like making a diverter arm or something like that, where, can I use acetyl? Yeah. Can I use a PET? Yeah. Can I use Hdpe? Yeah, probably. What about UHMW? Yeah, it's a little heavy, but you can use it for that. It's when you're using it just as a static part, or just something that is flipping hamburger patties over, or flipping a donut over, or something like that. It's a little bit different than when you're dealing with a dynamic component like a bearing.
So another question we have is it safe to say that the food industry in general, and not is now demanding contact plastics be blue.
I haven't heard that, and I don't know why that would be. Doggone it. I put some stuff in the presentation, but maybe I didn't save it or I loaded an old version of the presentation up. No, I don't think that that's true, because you can still get, and we still make, you can get metal detectable white, UHMW. In fact, one of the commercial bakeries that I do work with here in the Portland area and also up in Seattle, they've got a piston manifold that they like to keep white. The pistons inside are metal detectable blue, but the manifold itself is UHMW metal detectable white, and they like it that way. So I have not heard that all that stuff has to be blue. I could be wrong, but I haven't experienced that. And I think we would see that because our phones would be ringing off the hook for people ordering more blue than white.
Yeah, I'd have to check too, but I don't think that's the case either.
Or maybe that's a mandate that's coming later,
yeah, could be.
Because people, because the FDA, the inspectors want to see that visual level of detection. Don't know, haven't heard that, but I can see it.
So there's one more question.
Mm-hmm.
Is there an application where you saw exceptional energy savings?
Oh yeah, always. In channels. There was that one conveyor. Let's see if I can find it here. I don't know if you can still even see my screen. Oh well, I'll just stay right here. You see? Can you see that filled Ptfe bearing right there?
Yeah, we can see it.
Okay. So that is just it's a polymer housing bearing. It's in a high washdown environment. That would have a rolling element or a ball bearing in there generally. So by taking that ball bearing out, which requires, sometimes you can get them permanently sealed, or sometimes you can get them grease lubricated, externally grease lubricated, where there's a Zerk fitting on it. By taking that rolling element bearing out and putting in, that's a filled Teflon bearing insert in there. It fits right into the existing housing. You don't need to replace the housing. You don't even need to take the housing off of the conveyor unit. You can just leave it there or off the equipment, and then take the ball bearing out, wipe out all the old excessive grease, put one of these inserts in, and now that insert in there does not rotate inside the bearing housing. It will self-align in case you've got a bent shaft or a kind of a wonky mount on the housing. But the shaft will just turn inside that hole in the bearing, and it's not so much energy savings per se as much as just incredible savings, because you're not going to replace that bearing. That bearing could sit in there for decades. If the surface finish on the shaft is good, you never grease it, so you're saving money in greasing and labor. It's just going to work forever. As far as energy savings on motors, we see that a lot in chain channel, going from a metal channel to a lined channel. Anything that's chain driven throughout the factory, if the chain is riding in a metal channel, if you put in a plastic insert channel in there, you're going to see a lot less drag. We not only see that in the food industry, but we see it in the lumber industry, in the timber and sawmills. You see a massive cost reduction in running the equipment when everything slides more easily. You don't have, when you eliminate friction from any moving component within the part. Anytime you can eliminate that or lower that friction amount, your energy costs are going to go down, which makes sense, obviously. One leads to the other. But if you're looking at saving money in your overall operations, trying to get the grease out, because people have to buy the grease, you got to store the grease, then you got to use the grease, then you got to clean the grease, then you got to eliminate the grease, then you got to buy more grease. So getting grease out. I had one guy, and this is a number of years ago. This was in a food packaging place, and he said that he had to do a FOG analysis. That's fats, oils, and greases, FOG, and he had to turn these analysis reports in. So basically, it meant that he went around his facility, and I don't remember the time frame, once a day or something like that, and he would take a scoop out of all of the drains or the catch basins in the floor after the washdowns, and then he would send that to the lab upstairs, and they would separate out the fats, oils, and greases, and then they had to chart that out, and then they had to supply that information to the FDA and to the city and all that other stuff in the county. And he said of those things, the three things, the fats, oils, and greases, the fats and oils were coming off of the product, off of the fish. He said, but the grease was bearing grease. 100% of the time, every time. And he said, so if you can basically, if we can get all the grease out of my factory, we can get all the greased bearings out of here, 1/3 of all my headaches go away overnight. And that really stuck with me. And so over the years, we've been slowly converting all of the bearings out, all the grease lubricated bearings, and going, and that means a Redwood engineer going in there, measuring the loads, measuring the speeds, determining what type of bearing materials are going to work best for the bearing and give him the longest life. And like I said, this is the same factory where some of those bearings have been in there for 8-9 years, and they're still working. I was in there, what is this? Okay, so I was in there end of January, and I checked them out, and they're still there. That's with no grease. They haven't been touched, no maintenance, and these things get washed down every 8 hours. So there's no grease getting blown out onto the floor from the pressure washers. There's no way that grease can get into the food, even though these are non-food direct. These are just conveyor rollers. No grease is getting used, bought, purchased, disposed of, or ending up on the floor. So. I could go on all day about stories like this. It's amazing. Not just in the food industry, although I do particularly like the food industry because everything's perishable, everything's moving really quick, everything's dirty and fast, and it's just exciting places to work. So,
well, sorry,
should
Kevin,
I put did I scroll off of the phone number too fast if people want to email me? Or
yeah. Well, that's it for the questions that were inputted, but if anybody does have any questions, of course, you can reach out to myself. There's also obviously contact information on our website as well at redwoodplastics.com. And Kevin, I'm sure, is going to put up his own contact information.
There it is.
There you go. So I'll leave that up for a few seconds, and there'll be a recording of this sent out to everybody tomorrow as well. So if there was anything you missed, you can obviously go back and rewatch or share with your colleagues as well. So thank you everybody for joining us, and have a wonderful afternoon. Thank you very much, Kevin, as well, for presenting. It was awesome information.
Oh, happy to do it. It's always fun.
All right.
Thanks, Ken.
Have a great day, everybody.